So briefly, let's cover what you would do with quadratic equations that don't solve as simply as putting the x squared on one side and taking the square root. All right. There are three methods for doing so. One is factoring, if it's easy to factor. And now to complete the square and see what we get, we should get the same answer. I'm going to divide both sides by 2, make my life a little simpler. That gives me an x squared plus 4x plus 3 equals 0. Now, perhaps you recall that when you're completing the square, our goal is to achieve this, where all of our variables are locked away in a pattern like this. And this is important because we can rewrite that as x plus a quantity squared. And if all of our variables are there, then we can get that on its own side of the equation and then take the square root of both sides to get rid of the square. All right, so let's do that here. We need to have a constant here that is half of this square. That is to say, if this 4 is 2a, well, we need just a squared, right? So I'm going to start by rearranging them a little bit. Subtract that 3 from both sides and get it over there. And here I'm going to add my a squared. So if 2a is 4, a must be 2. 2 squared is 4. I'm going to add 4 to both sides of the equation. Must be on both sides or we're not. We've lost our equation. And now I can rewrite this as x plus our a value, quantity squared, and that equals 1. All right. Taking the square root of both sides, I get x plus 2 equals 1. Important note here, I forgot. Of course, when you take the square root here, square root of a square gives you the positive only, but we want both, so we do need that plus, we need a plus or minus sign there. Okay. So subtracting 2 from both sides, I get x equals negative 2 plus or minus 1, which gives us negative 3 or negative 1. And last but not least, let's solve this with the quadratic formula. This completing the square that we just did and this quadratic formula can both yield the imaginary solutions as well. Although, of course, since we've already found the real solution to this, we're expecting real solutions. Okay, so for this, for anything of this form, ax squared plus bx plus c equals 0. Anything of that form, and notice that a is not the same a we had before, it's different. Anything of that form has solutions like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? So that's the quadratic formula. Let's apply it here. We see that a equals 2, b equals 8, c equals 6. So that our x will equal negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 6 all over 2 times 2. So that we have a negative 8 over 4 plus or minus the square root of 64 minus 48 all over 4. So negative 2 plus or minus square root of 16 over 4. This is beginning to look familiar, I hope. There we have it. The solutions we had before, negative 3 and negative 1.